Okay, so we're going over 3.3 and now we're in the subtraction land. So if you know how to subtract, then you know how to subtract polynomials. Okay, so a phrase that I use very, very often in my classes, if it works in number land, then it works in algebra land. So we're in algebra land. If it works in number land, then it works in algebra land. So all those things that you learned in first and second and third, all the way up until the grade that you're in now, you take those things and now you're applying them to different parts of algebra. So when you're adding x squared plus x squared, it doesn't come out to be like circle. X squared plus x squared is not circle. X squared plus x squared is 2 x squareds, right? Like what's a sock plus a sock? It's 2 socks, right? Do you remember that in like kindergarten? They would say things like, Johnny has 2 apples. His mom gave him 30 more. How many apples does Johnny have now? Johnny has 5 apples because 2 apples plus 3 apples is 5 apples. Same thing goes here, except we're not adding apples. We're just adding x squares or x's or x to the fourths or whatever. So now we're going to talk about subtraction. And if you understand subtraction, subtraction is the inverse of addition. So if you understand how to add, then you know how to subtract. And if you understand how to subtract, then you now know how to subtract polynomials. So don't make this complicated and don't tell yourself that you can't do it. Because if you start telling yourself you don't do it, stop the video and go do something else because you're not going to be able to do this. All right, set your intention. Here we go. So subtraction of whole numbers works similarly to addition. Some people line up subtraction vertically and subtract bottom numbers from, subtract the bottom number from the top like this, boom, okay? So the very first thing they want you to do is write the analogous polynomials and then subtract them. So the very first thing I want you guys to do is write a polynomial like this. Now we did this before. I just want you to take the 2 seconds to make sure that you all have this done. So I'm gonna have you pause and actually fill this out. And then we'll be back to check your answers. Okay, so I went and picked in some of your answers and they look great. I do have to say there was a couple people that did it really, really well. So this person here did it horizontally and I really like this. So if you're into the horizontal, this is what it would look like. And then someone down here actually put it in parentheses, the second one. And I'm going to clip this only because this is going to help you remember. Where'd my thing go? Hold on. Wait, sorry, I had to find this. Because later on, it's going to help you remember what to do. Because this is actually the place where a lot of people make mistakes. So I'm going to take this snippet and I'm going to copy it right here. So the way this works is, yeah, you just do this. But the thing about subtraction that's different about addition is the subtraction has to go all the way through. Because if you just add it like, because if I just look at it like this, doesn't this look like 8 plus 7? Shouldn't that be 15, Miss Johnson? And 6 plus 5, shouldn't that just be 11? Oh, and 3x squared minus x squared is 2x squared. Do you see the problem with not having parentheses? So I'm going to encourage parentheses here. If you do, go back and put parentheses in there for me because that's actually going to help a ton. So I am going to encourage that. You don't have to do it, but I'm going to guarantee that you will make mistakes less. Okay, so this is that analogy there. And again, I do encourage subtraction. So is your answer to number 7 analogous to the whole number answer? So are these the same? Are these exactly the same? And someone says what? There's a little bit of a difference, Miss Johnson. There's a slight difference. What's that slight difference that I'm referring to? What's the slight difference between this and this? Yeah, they're polynomials. And indicative here, you're telling yourself 8 minus 7, 6 minus 5, 3 minus 1. Now, if you can do that, you're good. But if you're like me, I get lost over here. So I will distribute out this negative first. okay? So subtracting polynomials can easily lead to errors if you don't carefully keep track of your positive and negative signs. One way to do this is to change all the signs being subtracted, basically distributing out your minus sign. Do you guys all remember this? Like, so this minus negative times 2x cubed is negative 2x cubed. Negative times negative x squared is positive x squared. Negative times positive 6x is minus 6x. And negative times 8 is negative 8. Now, if your preference, like one of my buddies did it horizontally, if your preference is horizontally, then continue horizontally. My preference is vertical because I can line everybody up. When I line everybody up, though, I do change my signs, okay? I'm gonna like encourage that. So is it correct to change all the signs and add when subtracting? What mathematical property or relationship can you justify this action? So a long time ago, you learned this, and I just want to remind you of it. If I said, is there a different way to say 10 minus 4? And you're in 6th or 7th grade. Is there a different way to do 10 minus 4? Can you rewrite 10 minus 4 in a different way? Yeah, someone put it. Thank you. Thank you. Thank you. Thank you. I love when you guys do this. It helps me so much easier, right? Someone put it, and they even put it in nice little cute parentheses. The parentheses you don't technically have to use, but it does make it more clear, 10 plus negative 4. So the property that you're referencing here is this idea of subtracting a number is the same as adding that number's opposite. So subtracting a number is the same as adding that number's opposite. Adding that number's opposite. Got it? Okay, so Ms. Johnson, what? So what I want to say is when you're doing this and you see the subtraction, you could just add the opposite of that. Now, the opposite of 4 is really easy. It's negative 4. But the opposite of 2x cubed minus x squared plus 6x plus 8 is a little bit like, just make each person their opposite. So 2x cubed becomes negative 2x cubed. Negative x squared becomes positive x squared. Plus 6x minus 6x plus 8 minus 8. Now, I know maybe some of you are like, oh my gosh, that's a property, Ms. Johnson. That's something that I just knew. There's a lot of properties that you deal with that no one tells you, oh, that's a mathematical property. But now you're using it as if it is a truth that holds for all those numbers because it is a property. So the word property in math works like this. If you think about the properties, I've asked this before to students, and like it's really been a very interesting conversation. So listen to this really quick. Think about, so a property is something that holds true for that whole population. So in this case, we're talking about numbers, okay, in numbers. So I want you to think about the properties of a human being. What are some properties of human beings? What are some properties of human beings? Okay, so in the chat, go ahead, put it to the public though. Put it to the public so that everybody kind of sees what we're doing. Okay, very good. Some people's, okay, oh my gosh, you guys are so great at this. Okay, so some people say, Ms. Johnson, I'm gonna go in whatever order I want. Some people say, Ms. Johnson, arms. All humans have arms. Now, as I say this carefully, now listen to me. Do all humans have arms? Right? And so I'll say it a different way. If something does not have 2 arms, does that now make them not human? And the answer, of course, is no, Ms. Johnson. So arms technically are not a property of human beings, okay? So what would be a property of human beings? So someone says a heart, a brain, logical reasonings, like those kinds of things. So that would separate, and you're not necessarily thinking like what makes humans humans, it's just what do all humans have, right? And so, yeah, all humans in general have a brain that thinks logically. All humans have, and then you start thinking of, okay, in order to be alive, then you need to have a heart that's beating and stuff like that, right? So in order for me to use that property, in order for me to say this is a mathematical property, guys, when I subtract a number, it's the same thing as adding its opposite. That's a property for every single number ever. Okay. So that will also work with these numbers. Ms. Johnson, you just called those numbers. Yeah, those are numbers. These are numbers. 2x cubed minus x squared plus 6x plus 8 is a number. Like Sesame Street, they lied to you. X is a number. So therefore 6x is a number. You guys all see that? Okay. So what I want you to try right now is I want you to, let's see first, it says using the given polynomials to find the specific differences in A minus D, A through D. So here's the first one. It's L and M again, and they're going to have you do different things. So can you start with this one? This one says H minus K, H minus K. Can you start off with this one and see if you can give me the correct answer? Now, if you're horizontal, go for horizontal. If you're like, Ms. Johnson, I don't need to find the opposite. I'm just going to subtract across. Okay, go for it. I'm just going to tell you in my practice, in general, I tend not to mess with my negatives because that's, I think I've told you guys this before. My very first calculus test at UCLA, I got a D on the very first exam because it was a multi-part number, and the very first part of the very first question I distributed the negative wrong, and so from now on I distribute that bad boy like with careful thinking. Okay, so go ahead and do, actually, can you do H minus K, and you do F minus H. Do these first two and we'll check back in a second. Okay, so for this one, for this first one, H minus K, I'm just going to take snips of things because it's just easier because I can't scroll back and forth. Where did my snip go? Here it is. Let me just take this and bring this down here so I can take it. Okay, so for this one, H minus K, right? So they really just want me to do that over and over again. So I will do that, no problem. No, we're going slow again. Oh man. Okay, there it goes. So here's H minus K. I'm gonna just copy this. And I'm a up and down kind of person. I like writing them vertically. For 4x squared minus x minus 15. And as I bring this down, as I bring K down, I'm gonna make it opposite. So plus, that would be x squared minus 7x minus 4. Okay, let's just check to make sure. H minus K, so this minus this. So copied it correctly. X squared, good. Negative 7x, good. Negative 4. Okay, then I'm just going to add them up and down. So this is negative 19. This is negative 8x. And this is 5x squared. If you got that in the chat, go boom, I got it. Yes, please, 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 please. So then that's it. So nothing new here. Distributing is not new. This is, you learned the distributive property back in 4th grade, and then you applied it to expressions like this, probably in like 8th grade, and then definitely in 9th grade. Here, what we're doing is now we're just adding like terms, and then this is again back in 8th and 9th grade. Okay, so our answer here is this, and that's my answer. So I could just take this and plot this over here. That's what that equals to. Okay, f of x minus h of x. If, for those of you who want to do things horizontally, let's practice horizontally just for fun. So f of x would be x cubed plus 2x squared minus 7x minus 8, right? I think I did not leave myself enough room. That's all right. And then I'm going to subtract this. And as I bring it down, I'm going to change the signs. Okay. So I didn't leave myself enough room. So I'm going to scooch this over here. Okay. Then I'm going to subtract. And then I'm sorry, I'm going to add, and I'm going to change the signs of these as it pulls over here. So h of x is 4x squared. So now it's negative 4x squared Negative x is now plus x because it's the opposite, and minus 15 is now plus 15. Miss Johnson makes a ton of mistakes as she copies things from here to here. So you'll see that I check myself over and over again. X cubed, 2x squared, minus 7x, minus 8, plus opposite, negative 4x squared, plus x, plus 15. Yeah. Because again, going back to the definition, subtraction, or the property, subtraction is really adding the opposite. So here, I'm going to subtract f of x minus h of x by adding this guy's opposite, right? So then I just, collect like terms. I got no x cubes. I've got, let's see, I've got 2x squared. I like highlighting in colors because that helps me. 2x squared minus 4x squared is negative 2x squared, right? I won't continue. Negative 7x plus x is negative 6x. Negative 8 plus 15 is negative 7. So again, nothing new here. We're not doing anything new. So for those of you who are like, new section, it's not really new. It's like new and improved. You know how you always see those like, this is the car, it's new and improved. That's not new. It could either be new or it could be improved. It can't be new and improved, right? So this is like renewed, right? This is like renewed information. Did I put it wrong? Yes, see? Because I'm talking too much. Thanks, Alyssa. This is a plus 7. Man, Alyssa always had my back, man. I appreciate that, Alyssa. And so nice too. She's like, isn't that 7 a positive? So sweet. Okay, so x cubed minus 2x squared minus 6x plus 7, right? So then again, before Alyssa told me that, I would have checked my answers again. So x cubed, check. 2 minus 4 is negative 2 of them. Negative 7 plus 1 of them is negative 6 of them. Negative 8 of them plus 15 of them is 7 of them. Okay. Everybody good on that? Okay. Ms. Johnson, you always teach us ways that we can check our answer. How can we check our answer here? A couple of different ways that you can check your answer is if you plug in a value, just like you would if you were to graph it. Like for this one, I'd plug in, I don't know, the number 2. I'd plug in 2 here, get a value. I plug in 2 here, get a value, and I'd subtract those 2 numbers. A different way, an alternative way to checking your answer is if you went on to Desmos. That's not Desmos, Johnson. Let's try that again. So you went on to Desmos. So I'm going to check, let's check this one because I can see it all right here. So one of the ways that you can check it is, I said you can algebraically check it. So I'll go 4x squared minus x minus 15. And then this guy here is negative x squared plus 7x plus 4, right? So then what I would want to do is I would want to subtract these 2, right? So I'm going to subtract these 2. Oh, I told you algebraically first. Sorry, my bad. So algebraically, what I would do first is I would plug this in right here. And instead of putting an x here, I would just put a 2 in parentheses. I don't know. I'm plugging in 2 just because that's the number that came in my head. So I'm just going to plug it in there. Then I'm also going to copy this and calculate this at 2. So I'm plugging both versions in at 2. Okay. And then I want to subtract these 2 numbers. Negative 1 minus 14 is negative 15. You're like, Ms. Johnson, there's no negative 15 here. Hold on. Be patient. Okay, so then when I plug these both in together, my actual function here, this is my answer, I should also get that same number. So let's see, 5x squared minus 8x. Ignore the graphs for a second. I'm going to use them in a second. So I want to make sure that when I plug in this number here, when I plug in a 2 here, right, I actually get the same value. And again, plugging in one number isn't going to guarantee that you're right, but it's confidence towards, I think I did it right, but it'll definitely tell you if you did it wrong. So negative 1 minus 14 is definitely negative 15. Woohoo, right? So my first little check is correct. My second check is going to be to actually subtract these. So I'm going to do this. Hold on. So I'm going to copy this. put it on its new line. And then I'm going to subtract, and I'm going to put parentheses, and I'm going to put this whole thing here. You guys all see what I'm doing? Okay. I'm going to turn these two off. Okay. Do you see the black one? Someone's like, Johnson, I don't see the black one. You're right. Let me turn the blue one off. Tell me what I should see happening. What do you guys see happening? What do you see? Yeah. What does that mean when they're on top of each other? Yes, they are equivalent. So there's a couple different ways for you to check your answers in terms of polynomials. Your graphing calculator is such a powerful tool. Okay, and because you guys get to use it, use your calculator. Okay, it's an advantage, not a disadvantage. So that's how I would check my answers, just to make sure. I can check algebraically, I can verify. And so remember when Alyssa so kindly said, hey, Ms. Johnson, isn't that a negative one right there? When I would have checked my work, I would have found that that was wrong, right? By plugging in a value like I did here, or when I compared my two expressions like I did here, black and blue, right? Okay, so I'm gonna then assume that you guys are all okay with C, D, and E, except for I want to go over this just to make sure that we're all on the same page. So if you notice, L and M are the same. So I'm gonna like literally copy this chart that I have up here. Here it is. So because I already have this chart, I'm gonna copy it and I'm gonna use it to find L minus M. Let's see, where do I put this? Right here. I wanted to find L minus M, right? So here, this is L plus M. I don't want L plus M. I wanted L minus M. So literally, you're just going to subtract. So this is going to be L minus M. So you're doing the same thing as before. You're coming up here, you're finding a value, you're saying 0. That's 2. And 0, oh, that's 1. So you're going to go 2 minus 1. So this is going to be a 1. And you're going to go 3 minus 0. And you're like, oh, that's a 3. 7 minus negative 4. Oh, that's an 11. So then you would plot these points and you would see what they are, what it makes. So we already figured this out up there. We found that L and M, where's my L and M? Here's my L and M. Let me just copy this guy. Copy both of these other things. I'll grab these, bring them down here. Slow. All right. So the point of this is to show you that you would still get the similar thing. Okay. So here's my L and here's my M. Here, I'll just leave it here. And then when I subtract them, right? L minus M, what's X? Minus negative X. And someone says, oh, that's 2 X's, Ms. Johnson. Good. What's 2 minus 1? 1. So that's 2x plus 1. So the function of L minus M is 2x plus 1, right? So that's what a function would look like. Okay, tell me 3 important things to remember when you're subtracting polynomials. What are some important things to remember when you're subtracting polynomials? Okay. Yeah, number 1, line them up correctly. So someone says, Ms. Johnson, don't forget to line them up correctly. Exactly. And then Ms. Johnson, make sure you're subtracting correctly because you just subtracted wrong up there. Yep, that's me. I will tend to subtract wrong. And that's why I'm really careful whenever I deal with subtraction and distributing a negative. Someone else said, hey, Ms. Johnson, keep track. Oh, distribute the negatives. That's another good thing. And this is a suggestion. This one is not a hard rule. So if you don't want to distribute that negative, but I'm just going to tell you, I warned you. I warned you. I warned you. I warned you. Keep track of your negatives and positives. Very good. Is there anything new that I taught you right now? Is there anything new that I taught you? Everyone says, oh, Jonathan, so the same thing. We just applied it to the very, very new. Yeah, that's another good thing. Very good. Let me grab this one thing. If your graphs are wrong and they don't line up when you're checking, then you did something wrong, right? Very good. And then you apparently don't have an Alyssa checking your work during your test. So you might get it wrong. Okay. So that is subtracting polynomials. You should be comfortable with this. You are actually hoping, Ms. Johnson, I hope you give me a lot of questions like this on our test, because I'm going to do really well on this part, right? Very good.